Welcome back to another episode of Heavy Wireless, part of the Packet Pushers Podcast Network. And today I'm going to be talking about a really terrible word. The word is survey. And we've been using the word survey in the wireless community for 2 decades now. And for me, it's one of those words that has so many meanings that it's really hard to pin it down. Today I have with me Jussi from Hamina. He used to be with Ekahau. And we're going to be discussing the past, present, and future of surveys. Welcome, Jussi. How are you doing today?
I'm doing fantastic, Keith. How are you? Thank you for having me on.
Glad to have you. I was thinking about the word survey and how it means so many different things. A couple of years ago, I built a new house, and the first person to come on site was a surveyor who surveyed the land, and I had a survey from the land. The people who put in the sewers came and did a survey. The electricians did a survey. The plumbers did a survey. And putting in the Wi-Fi in my house, I did a survey. So for the last 2 decades, we've been throwing around this word survey. What does survey mean to you?
Well, to me, that's actually a good analogy of like different types of surveys. To me, it's somebody doing some kind of an on-site assessment of a property, facility, or environment. And I would like to highlight the on-site. So, for example, if I build on that, the architect didn't do a 3D CAD survey when he designed your house, right? They didn't. It's not called that for a good reason.
They did a 3D. They did a 2D drawing, and then to help my wife visualize where things were going to fit, they turned it into 3D so she could see what was going on. Yeah.
But they didn't call it survey, did they, at that point?
That was a design.
Yep.
But in our industry, the word survey kind of got stuck. If we go way back, 20 years ago, when I would design Wi-Fi, we would go on site and stick up an AP on a stick, and if we had a stick, if not, we just left it on a desk. And then we'd put it in the corner of the building, and we'd walk until we hit some target, and then that would be the first place we put another AP. Being that if it went from the edge to there, then it would go from that location back to the edge. And that was our first one. Then we'd repeat, move it, repeat, move it, repeat. And that was a design. It was on site. It was physical. I wouldn't even call it back then an AP on a stick, because it was just using an AP to see how far coverage went, since there were no tools to let us visualize that. Then the next step, we came across Air Magnet and Ekahau at the time, and you were with Ekahau back then. And what was the design goal of Ekahau in the beginning? What were you trying to design for?
So I guess the first version of Ekahau was like to replace the paper and pen method, where you would have your compact iPad with that AP on a stick. You would carry your compact iPad, you would look at the signal strength indicator, and then draw the numbers on a paper that maybe it was a floor plan or things like that. The first goal of the Ekahau site survey 1.0 was to automate that process and kind of, draw nice color-coded heat maps based on a single walk around the site without having to, mark those numbers on a piece of paper.
And I spent many hundreds, if not thousands of hours walking and writing down on the floor plan the RSSI value, and then going back to the hotel at night and playing connect the dots, connect all the neg 67s together, all the neg 72s together, and end up with a topo map kind of manually built. So the first rev was a huge success. It was way better than walking around by hand. But that was just measuring a single AP. What was the transition from that into the actual design phase, where instead of collecting the data and turning it into a heat map, you could predict what would happen if you stuck an AP someplace?
In our case, I believe that came, and typically these things come from customers, right? When they see that you can actually map the physical environment by walking it, then the logical next step is to not have to walk it. But then the question is like, which one is more work, the actual walking or just doing some kind of predictive, site design on a predictive tool. But the idea was like on-site and truck rolls on-site are expensive. So there has to be a way, and maybe both are needed actually. The other question was, how do I figure out like the initial locations of the APs? Like how do I determine my access point on a stick locations? And predictive obviously helps with that as well. So you can either like that also gave the users options of like, okay, let's do an AP on a stick survey, or let's do a predictive, or better yet, combine both, and kind of making the predictive also can make AP on a stick a lot more effective, because you probably better figure out the initial locations, because each AP on a stick placement, it takes quite a bit of time to survey.
And it would help to have and I think really what I was trying to set up here is initially we did surveys. We went on site with our tools and we walked around and collected local data, which is how when we moved to that next phase, when they were predictive, we still used the word survey, because the end result was we still got a heat map. But the difference was we're not actually surveying, we're doing a design only. And thus we now have the word survey that means two different things.
Yeah, I don't know how that, like how we got there, where we started calling predictive a survey. I may be guilty of that. As far as I can remember, and this is my bias, but we tried to stay away from that. I think from the beginning, at least that's what I'd like to say. But I can totally see it, because the end result looks similar, and many cannot, like outside of the, if you're not in Wi-Fi, you probably cannot differentiate whether it's a predictive heat map or a measured heat map. For the layman, it's just a heat map, and if it's a Wi-Fi heat map, it equals survey. So I can totally understand the train of thought and where we kind of got the terminology a little bit wrong.
After the terminology got reassigned, because you're right, they look the same, people would sell a survey and say, we want to sell the survey. And then what some companies would do, they would do predictive only, because it's way cheaper to not physically go on site. And if it was called a survey and it looked like a survey, then people had a lot of faith that the predictive only was true. I'm of a position, I think, no matter how you did the design, you always need to do a validation survey where you're physically on site collecting that data. Now, friends of ours like Sam Clements and many others will do AP on a stick surveys where they physically go on site and put the AP everywhere that needs to go. It's a very expensive proposition, but if it absolutely must work the first time and no changes, that's the best way to get there. Personally, I like a hybrid where you do a predictive and then you go on site and validate it. And if there's any mistakes, you learn from your mistake and you get better and better at doing the predicting. But you always have to have that validation to lock that real world in.
Just a brief pause to ask, did you know Packet Pushers has a job board? Whether you're looking to find or fill your next great IT infrastructure role, the Packet Pushers job board is the place to go. It's easy to post, easy to browse, and easy to apply. So whether you've got IT talent or you're looking for IT talent, visit jobs.packetpushers.net and get to work. That's jobs.packetpushers.net.
You've come across in your career each of these phases. But today you're with Hamina, and in the last couple months, I've seen you give presentations on the next phase, and I'm going to murder the word, of surveys. Because we went survey on site, we went survey off site, we went predictive, we still call them surveys. And now you've come up with a way of getting the same looking heat map, but without going on site at all and not predicting. What's the process you're using now?
Oh yeah, this would be the point where I would show a massively nice slide, a diagram of the whole thing. But yeah, it and I like how you said similar looking heat map, because it is not the same thing, but it still doesn't mean that it wouldn't be valuable in validation, and especially like on site, like troubleshooting survey, stuff like that. The idea is that a lot of today's networks are API driven. You hear this word API driven and automation and all of that all the time. For us tools vendors, this actually lets us kind of escape our box where we've been living for the last 15, 20 years and gives us more opportunities to become not just predictive tool vendors and not just, site survey tool vendors, but also like kind of try to grasp the entire life cycle of a Wi-Fi network and make it visual and make it understandable and things like that. So what we do...
Just to interrupt for a second, you want to back up and explain, You use the word API? Some people might not know what you're talking about. What is the API, and how do you use them in your software, and how does that process work?
Absolutely. Great question. So API is a programming interface which allows our software to tap into an enterprise network and query the enterprise network for certain data, such as, our software could tell the enterprise network, give me the floor plan of the facility. It could say, give me the locations of the access points on the floor plan. And it can give more, like give me all the radio properties of all the APs, like channels, channel widths, everything. And finally, I think the new thing that we've now been pushing together with the vendors is give me readings of how every access point here's every other access point. So this like quite sizable matrix of how for every single access point in the facility, how do you hear everybody else?
And does that include everyone who's not part of that network?
It can include neighbors. But for this, like what we call environment modeling, we do not use the other access points because we don't know the locations of the other access points. So it doesn't help train. It doesn't help us understand the environment. For us, for our tool to understand the environment without having to draw any walls, without having to do any site surveys, what we need is the exact known locations of access points, as well as what could be called RRM neighbors or radio resource management neighbors, or access point to access point RSSI readings. So we need to know the AP locations and know the RSSI readings of each AP as seen by each AP in order to have enough knowns to map out the unknown. And the unknown in this case is how is the attenuation all around the site that you're looking at. So our end goal here, in this case, we're using the API to build an attenuation map of the entire site. Instead of drawing walls, instead of performing site surveys, we're looking at how all the access points hear all the other access points. And of course, it comes with pros and cons, which I'm sure you will come to.
So on the pro side, you don't need to go on site. On the con side, you have to have Wi-Fi already installed. On the other hand, it's been a long time since not rarely, but new buildings happen, and we do have greenfield, but most of our work is brownfield. And so they already have something up and running. Think of another con of this. How ubiquitous is enterprise systems' ability to send you this information? Do all vendors support it? Is there like a rev, 3 years old, it's good, but 5 years old, you couldn't see it kind of thing?
That's the thing. The amount of programming interfaces or APIs that the vendors provide is absolutely vendor dependent. Some vendors provide more, some vendors provide less. And with almost all of the vendors, we are working to expand their APIs, and we already have, even for some vendors, we tell them like, this is the set of APIs we would need, and then they build a whole set around our requirements. But it is indeed the case that not all vendors, for example, not nearly all, support this access point to access point, readings.
How about the location of all APs? Is that also something that's fairly normal?
That's fairly normal. So assuming the user has at some point either imported the maps and the floor plans from a design tool, or the user has manually placed the floor plans and the access points on the system, then it's usually available through the API. That's pretty basic stuff, yeah.
I'm just going to back up a second. And one of the things that you offer on the API from your side is I could get a floor plan, do a design, do an install, and then with Hamina, I can have Hamina send that to my enterprise network management system.
Correct.
So having the floor plan in the network management system can go either way. I design and then send it up to the network, or in this case, what you're talking about, it's already up in the network somehow, and you're downloading it back again.
Exactly. That's a good point. And we do use these APIs bidirectionally. You can also push things into the network as well. So like you said, the process could be design a network with Hamina, click a button, and we create the site, we push the floor plans, we push the access point locations, but we also commission the access points out from the inventory into the site. So if you have typically these enterprise systems have organizational templates and things like that kind of, it's the organization-wide configuration of the network. If that has been set, you can commission new sites directly from Hamina, for example, without ever going into the Mist or Meraki dashboard to create these new sites. So we can commission them directly from the RF design tool, which is, it can be convenient.
Let's talk about walls, because we're going to come back to the current API system. So historically, we've had a wall, and the wall has RF attenuation. And for years, we've been teaching people how to measure those so that when you're in the design phase in some design tool, you put a wall and you give it an RF attenuation value. And then after it's installed, you validate it and you see, the walls I put in were correct or they weren't, and we adjust.
Mm-hmm.
In this new system where you're pulling the data from APIs, you're not getting any walls.
Correct.
I mean, they might be on the floor plan, but you're not using the floor plan to build a wall. What's the? I don't want you to share any secret sauce, but what's the idea of the algorithm of how it builds that attenuation area based on the AP to AP communications?
So, indeed, the bonus of this is no walls needed. And what we do is we look at the AP to AP communications, and we do not know what exact walls are between the APs, but we do know the attenuation of signal between every AP. So we can, if it's an enterprise network of 10 or more access points, for example, even 5 or more access points, we can start to, deploy you could call it an attenuation map around the site. So think of attenuation instead of like wall-based attenuation. This would be almost like an area, like small slices of areas, and they all have different attenuations based on the matrix that we got from the system. So it's really an area-based attenuation that we're building. And then, of course, we also account for things like access point height, things like that, in order to three-dimensionally try to propagate signal as accurately as possible. And the way I see it is this has 2 key use cases. Number one, when you're doing remediation or troubleshooting, usually the RF understanding of the site happened only after somebody went on site, did a physical site survey walkthrough, and then you could assess like the amount of interference and the actual coverage and things like that. But this allows us to like not have to do that. So before doing a truck roll, you can already get a fairly accurate understanding of the RF in the site when you're troubleshooting. The other one is like before you do an actual validation survey on the site, you can get a like a rough level validation of the site by just looking at AP to AP. So if you've connected your APs and you're kind of ready for the validation survey, even before going on site, you can spot drastic mistakes in your plan using the AP to AP or kind of using the live network view based on AP to AP readings. But like you said, we are used to like drawing walls and things like that. That's fine. If the walls are all the way to the ceiling, this system works really well. But the drawback is if it's a warehouse where APs may see one another really well, but the client level is totally a different animal. There's no way around it. This will not spot your design mistakes. I wouldn't bring this to a warehouse. I would not bring this to a factory and say, we need to make design changes based on this system. No. But for carpeted spaces, hospitals, hotels, offices, things like that, normal buildings, it is useful. It is good, but use with caution. It should have almost like a cigarette box has this Surgeon General warning. This should have some kind of a... Yeah, exactly.
What about label. Places, if the original design was lacking in some sense, like there wasn't an AP in some corner, that corner would then have no information that goes into your model because you're only talking AP to AP. So if, say, it was the CEO's office and he didn't want an AP in his office, but now you don't really know what's going on in his office.
Yep. That's the other one. We kind of try to be smart at extrapolating outside of the rubber band that surrounds all the APs. We try to do a fairly smart job at extrapolating beyond that, but you cannot know. You're right. You cannot know.
It's what I call a one-way guess.
Yes, sir. Absolutely.
You only have it out one way. The two things you mentioned, you're troubleshooting, you're trying to remediate a problem. The other is you're about to go on site and do your actual validation survey, and you can learn things in advance. How about, what are some examples you could use this technique for troubleshooting?
So the way I would look at that is, first, I would go to the vendor dashboard and look at the obvious things like alerts, things like that. What does the AI say? And just an overall glance of the site, the usual health metrics that they give, usually in graph format. But at least for me, I'm a very, very visual person. And we just discussed about this actually with Jiri Breccia from Cisco yesterday. But it comes very much down to a preference thing. Do you want to look at graphs or do you want to look at the floor plan? And how is it? How do you like to do your, for example, RF analysis? To me, for RF analysis, floor plan is really, really good and useful. So after looking at the vendor dashboard, I would look at what we call the live view and try to understand the overall RF situation on the site. Coverage, secondary coverage, channel utilization, non-Wi-Fi channel utilization, Wi-Fi channel utilization, and interference. And get a quick glance of the sanity check of the channel layout. But of course, interference will show you whether your channel layout and channel width are in check. But those things you can check out quickly from the live view. And to me, looking at those things, a map floor plan makes more sense than a table or a graph. But that's very personal. And many people swim in vendor dashboards day in, day out, and they prefer to use that. So yeah, I don't know if I answered your question, but at least I got a long monologue out of it.
I was thinking of a third method you could use this technique. Let's say you had a Wi-Fi 5 install and you don't have any 6 gig. After you've collected this live data and I don't have the budget to go on site, can I use this data as the starting point to do an upgrade to a new 6 gig system?
I love the question, actually. And that's very much a key use case for this. And you can actually copy and paste the, we separate the design into 3 different buckets. We separate them into, in our tool, they are tabs, but different tool vendors do it differently. For us, it's a tab called simulation, which is the planning phase. And then we have a tab called survey, where all the survey data lives. And then we have a tab called live, which is the live network status. So you can, you just go to the live tab, you get a control C, you copy the live APs and paste them into simulation to create your sandbox of this is my current situation of the network. And then let's say but in the lack of a visual demo, I would just, command A, select all access points, and then I would change their model into 6 gigahertz capable AP. And there you go. You have your 6 gigahertz coverage with the current setup. And then you could, on your sandbox, you could start adding access points, moving access points, and kind of make your future plan out of that. And the beauty here is no walls drawn, no surveys done, and still with some level of accuracy, you do get a decent plan out of it.
Have you done any head-to-head comparison on a known site with known walls and then reran the live and see how close it was to the original?
I have. And it is, for being the first version, I'm really liking what I'm seeing. And like spotting drastic problems, like I completely misestimated my walls or things like that, like the attenuation of the walls, things like that. I think it provides value for that, and I think it provides value for RF troubleshooting and analysis.
And by its very nature, it's going to be fuzzier, not as precise, but the data is still there. Well, Jussi, thank you for helping me take our audience through the past and where we are now and where our future might be. We started with the word survey, and might I suggest you change your word survey, because you've got survey on a tab. And which survey? The walk-around survey, the validation survey, the predictive? Yeah, anyway, just teasing you. At the end here, you want to take just a minute and give us an elevator speech for Hamina. I know you've never talked about your company before, but it'll be a little pressure.
How should I say it? So for designing, deploying, and maintaining really good wireless networks, they don't come by accident. You need some kind of tools for that. And we're kind of trying to raise the bar when it comes to usefulness and efficiency and science of the tool, and kind of utilizing like these things like APIs and being the modern browser-based choice. But we're lowering the barrier. We're raising the bar, but we're lowering the barrier by making it starts at $390, very inexpensive. It's very easy to use. It's browser-based. You can start for free. I guess raising the bar while lowering the barrier. That's how I would summarize it.
Well, thank you very much for this time. You've been listening to another episode of Heavy Wireless, part of the Packet Pushers Podcast Network, and we look forward to talking to you in the future.